Good morning and welcome back. If you've been following my videos in sequence, which you may not have been doing, you'll have seen me start way back in Scratch and use a block-based language a little bit to contrast that with Codesters, which is another way to learn Python. And then we came to this space, which is Spyder. This is an IDE that comes with the Anaconda distribution of Python. So does Jupyter Notebooks and some other stuff. So what I'm going to do in this video is continue to develop this tiny world I have over on the left, which is inside of a saved file called intro underline Python. And Spyder automatically sets it up with the date and so on. I started this quite a long time ago, and so the date looks kind of old. I'm sure there's a way I could put today's date. In fact, let's do that. It's still a Tuesday, but it is September 26, 2017. This is what we call the doc string of a module. It's where you put overview for your readers, people who are going to be using your code. Okay, so my goal here is to morph this dog into a more generic animal class, and also to add a couple more classes, give you the sense of how Python's grammar, how all the pieces fit together, how they all mesh. So think about just a basic list, and let's call it a zoo. I'm not saying I think zoos are the greatest thing. They can be a sad place. They're kind of like prisons. But on the other hand, we're preserving some endangered species with no fault of their own, as they're being wiped out in some cases. So let's put a bunch of, animals we like into our zoo. These are just of type string. So if I go into the zoo with my indexing here, the square brackets, remember the element number one is the tiger, because element on the left is element 0. So we start numbering from 0, right? So the type of that object, by type I mean, is it a car, is it a truck, what is it? It's a string, str. So, anything in quotes, single or double quotes, is a string type object. Now, what we'd like to do is have some animals in our zoo that aren't just simple strings, but are more customized to be animals. Because strings and animals, those are different things. And we'd like to, the species, I guess species is what we say, right? What is your species? Or species. Like, are you a human or are you a gorilla? That's a species, right? And given we're going generic like that, let's not bark, because barking is something only dogs and some other dog-like creatures are into. Seals bark, but just about every animal eats, right? I mean, that's just almost part of the definition of an animal. So when an animal eats, what we want it to do is append to its stomach. And every animal person is going to have a stomach, which is going to be a list that's going to start out empty when the animal is born, but by the eat method, we're going to be able to add food into this animal. So I'm starting with an empty stomach, open, close, square brackets. So here's a little more evolved than we had before. Now over here, I haven't run this code yet. I haven't even saved it. I've saved it now. Over on the right, the REPL here, the interactive Python, is not yet aware of any animal class, because I have not run this code. It still knows about dog from last time, because I've run this code before. When you in Spyder, when you run code on the left, the names that you define, like animal, show up then as usable on the right. Like using the old dog class, I could create a new dog right now. Let's call him ODog for like dog object. He's an object dog, and I remember that he takes a name upon birth. That's it for dogs. And so now O dog is this object of type dog, right? And inside of this dog, actually, we can look inside. The dunder dict of this dog is where this instance keeps its name, for example. And that's all that the dog had was a name. Now I'm going to run this code on the right, hit the green arrow, and it runs. It's still, let's see, it's still managing to find the dog, even though I've taken the dog out. It didn't seem to have any trouble creating a dog because it's still in memory somehow. That's interesting. So what I'm going to do anyway is change this to animal the way it should be. And I'm going also to make this a zoo, this list. Now this zoo list is going to become a class in its own right, just like animal is, ultimately. But for now, I'm just going to have it be a list, and then I'm going to be appending these three animals to the zoo. It's still interesting to me that this code ran no problem because there was a shadow dog still in the overall namespace. When you're in Spyder, you're kind of inside the mind of Python, and it still remembers stuff. Like, if I do a reset over here, it's going to forget everything on the REPL side. It's no longer aware even of dog at this point. It's only got the built-ins, the bare minimum. Like I've just erased the blackboard, basically. So now on the right side, I'm still refactoring here. Let's call this any animal. Why not? For any animal in the zoo, we're going to say the name of that animal. My name is Blatt. So far, I don't see any troubles. And now I'm going to run this in a second. And they don't bark anymore, but they can eat now. So let's test the eat method. We're going to eat. Not all animals like to eat the same thing, but we're going to eat a food pellet. That sounds pretty generic. Any animal should be able to eat that. Now I'm still seeing some issues. The main issue I'm seeing and why this code would not run is on birth, animals expect to be given not just a name anymore, but I've upgraded to where they want a species as well. So here is where we can say Rover is a lion. Now that doesn't sound like a lion name. And Fido doesn't sound like a tiger name. And Molly is going to be an otter. Well, maybe that sounds more realistic. Maybe, I don't know. So let's run this code and see what we get. So everything went fine there. The eat method doesn't return anything. Notice there's no return value. So that explains what these nones are coming back. It's like every time I eat, I get a return value of none from the eat method. But now we have these objects inside of zoo, and I can say zoo, and there's my three animals. They don't represent themselves in a beautiful way. I could fix that right now. Before I end this video, which has gotten long enough, let me add one more method called the repr, and this will say how we want these animals to represent themselves when they're asked to. And we're going to return a string that says animal, and in parentheses, now these are going to be called placeholders. I put open close braces inside of a string, and then I use the format method to pass in self-name and self-species. Okay? So here we go, run it again, and this time, when I ask to see the zoo on the right, the representations are much prettier, right? It tells me I've got a lion, a tiger, and an otter. Now let's take one of those animals. Let's just take the leftmost animal, which has a name of, oops, spelled that wrong, which has a name of Rover, Rover the lion. Okay, let's feed Rover, who's in position 0. Let's have him eat a fish. I think a lion would eat a fish under duress, perhaps. There are other things lions would rather eat. But okay, let's just do that. And now let's look in said lion's dict. And there we see he's remembering the object is name, species, and so far 2 things in the stomach. So remember before we could initialize, when you're, let's take another animal at random and give it a name. Let's say zoo tiger equals zoo 1, okay? Because the second animal is Fido the tiger. Second animal meaning in the middle of these 3, okay? And let's look in this tiger's stomach. Food pellet so far. Haven't fed it any fish or anything else. Now we have the power in Python to do this. I can just make up an attribute out of the blue, like mood, and say that the tiger is moody. I've seen moody tigers. And so now let's look in the dict of this particular object. Dict, dunderdict. There's the mood for that one. The others are not thereby going to have mood. Just because I added mood to one instance of the animal type, that's not going to propagate. It's not like the other animals now have some mood. If I want to add new things that all animals get at birth, I need to start writing that over here. Like if I want there to be a mood attribute common to all animals, which I'll initialize as none to begin with, if I do it on initialization, then all the animals are at least going to start out with sort of a placeholder. But that's not what I did. This code was not there when I ran it, so I'm taking it out now. And that's why I say when I go back and look at the lion in Zoo 0 and peek into his stash of knowledge, there's no knowledge of any mood, right? It's just unique to the tiger at this point. Now, as a last final thing, let's say I want to be able to feed any of these guys. Well, as a final thing, I'm going to do 2 things. First of all, I just want to be able to call them directly. In other words, instead of saying zoo tiger eat fish, let's eat something else. What do tigers like to eat? Dog food. For some reason, we ran out of tiger food, and it turned out that the tiger liked dog food. So now we have those 2 things in the tiger stomach. What if we just want to be able to do this? Zoo tiger, open parentheses, gazelle. They like to eat gazelles. Okay, it doesn't let me do that right now. It says this animal object is not callable. You can't just put open close parentheses right after an instance of animal and expect it to do anything. Why would you? Where's the code for that? Where do you define that? Well, how do you define that? You do it like this. Dunder call. This special name is what you need to implement if you want incoming arguments, or maybe you just want, no arguments, but you just want to call it for some reason. You can get fancy with how you do your parameters, how many arguments, and all kinds of things. I'm going to keep it simple and just have the one food as usual. And under the hood, I'm just going to call eat and pass the food on. Like I've already got the code for it to append to the stomach. So behind the scenes, I'll just have this method call invoke that method. So in a way, I've got a sort of a synonym going. 2 things that mean the same action, basically. I'll rerun this, and I'll go back into making my zoo tiger be item 1. And now I can do the following. I can just call and say, you get to eat a fish. And now if I look in the zoo tiger's stomach, lo and behold, that worked just fine. Notice it started over from scratch because I reran the code. Everything was reinitialized. Now for my last trick, I'm going to make the zoo itself be a class. So we're just going to go like this. And it has it has an initialization method. It just has no arguments. Self comes in sort of magically because by the time you're initializing, you already have a self, and you're just sort of post-production. What does my self need? In this case, self needs animals. What we're going to put in the zoo, it's kind of like the stomach of a zoo is the animals that it has. And then we're going to have a method that I'm going to do in another video called feed animals, which is going to feed all the animals in the zoo. And for that, we're going to need a zookeeper, another type of object. So we're not up for this yet. We can't actually do this yet, but zoo we can do. The final thing is we want to add animals to the zoo. We're going to say add animal self, and then we're going to have an incoming animal type. So instead of passing in the strings, we're going to add animal, and this is going to do the obvious thing. It's going to append to the list animals, whatever we passed in. Okay? Remember, animals is this empty list. So we're just going to append what animal we pass in. So all we have to do now is change these appends to add animal, because in the future we're going to be talking to a zoo type object, which we have to also give birth to. Haven't done that yet. So we don't have an empty list anymore to start with. We have to create an instance of the zoo type. So zoo is, give me a zoo, please. That will run the init method and get your zoo going with an empty animals list. And then we're going to add animals several times, 3 of them, to get our lion, tiger, and so forth. So can we iterate over this thing just because we've, put them in a zoo? How are we going to loop over them now? How does this allow us to loop over it? So actually we have to implement that as well. We basically have to say, when you iterate over me, what I'm going to do is give you back just this list called animals. Just go iterate over that, okay? Just, that's what I want you to do. When you have to loop over me like this in a for loop, I just want you to treat me as if I'm the list animals in that case. So then everything should work. I should be able to feed them. Let's give it a run. Save it. Run. And we had problems. The iter required a positional argument animal. So yeah, it's like that. I didn't need an argument for that. Iter is just telling Python how to treat the instance, the zoo, when I for loop over a zoo. So now it knows how, okay? So now I can look inside my zoo and say, hey, let me see the animals in there. And it says, oh yeah, I've got 3 animals, these guys. And I can say, oh, let me look inside the zoo animals. Got to get the point right. Look inside zoo animals 1 into the stomach of that animal. And it's like food pellet. Anyway, what is that animal? Let me ask. Oh, Spyder the tiger. Okay, so all this code's working, and you now see how the development process works. What we would also probably be doing pretty soon here is starting to write unit tests in another file so that I can do kind of a cross-check and make sure that as I continue to develop, I don't break things that already work we can talk about that in another video. So there we go. That's life inside Spyder doing some development. I hope that was elucidating. Talk to you soon.